Let's go. Good morning, troops. I hope you guys are having a great day. I, right now, am probably somewhere in sunny Florida. That's right. Wish you guys were all here, but you ain't. So that means we got to do some empirical formulas. I know, exciting, right? So, what is the purpose of an empirical formula? Empirical formulas are the simplest whole number ratio. So like when new medicines and drugs are synthesized in a lab, they have to come from somewhere. Okay, so there has to be a base. Like all carbohydrates start with a general simple formula. Okay, so when a new formula is synthesized in the lab, its formula must be determined from the amounts from each of the elements that have been combined. Okay, so we're going to be dealing with all sorts of elements and seeing the combination of them from some math today. An empirical formula is the simplest whole number ratio. So, folks, star it, underline it, do whatever you need to do. That's going to be a test question, quiz. Okay, simplest whole number ratio is what an empirical formula is. So, the rules. First things first, convert the mass of each element to moles. We've done this before. So let's just jump right in, and I'm going to go through each of the steps as we're reading them. So here we have 27.93 grams of copper. We also have 7.07 grams of sulfur. So you know that at the end, our formula is going to contain some number of coppers, and it's going to contain some number of sulfurs. Okay, so just like we have been doing all along, is convert this to grams. Both of them. So if you have grams here, you have to have grams, and that always equals a mole. So grams here, that always equals a mole. So the mass of copper, if you look up on the periodic table, 63.55 grams. And then sulfur is 32 grams. So let me take my handy dandy calculator. All you funky chicken calculators out there. That's right, Sarah. Talking to you. Did you like the funky chicken the other day, Sarah? That was right. Everybody did. That was awesome. I went out in the hallway and followed people with that thing. Okay, so when you divide 2793 divided by 60.55, you get 0.439. Let's just go one more. 4395. 7.07 divided by 32 is 0.2209. 0.2209. Okay, so we have converted each of the given samples into moles. Okay, now, this is what we call a mole and mole ratio. Simplify the mole to mole ratio by dividing each of the mole values by the smallest mole value. Well, here are the mole to mole values. We're going to divide both of them by the smallest mole value. So in this case, boom, 0.229. Now, you could have 2 of them, you could have 3 of them, you could have 10 of them. Divide all of them by the smallest. Well, you know what this one is. 0.229 divided by itself. That's right, it's 1. And look at this, 0.434, that looks like half, so that's going to be a 2. So, use the resulting whole numbers as the subscripts of the chemical formula. So look at this. Cu now has a subscript of 2. S has a subscript of 1. But remember, we don't write ones. We're just going to leave it as an S. So the empirical formula for this one is Cu2S. Pretty good, pretty good. Now, here is going to be the same problem, except different from this one because they are in percentages. However, percentages are based on 100, So if that is the case, then what we are going to do is just simply ignore all of the percent signs and just make them grams, because they're all still going to be proportional. So we are going to have 26.6 grams of potassium. We're going to have 35.4 grams of chromium, and we're going to have 38.1 grams of oxygen. So that means that our formula is going to be K, Cr, and O something. Okay? So, let's change them to moles. If you're ready, I'm ready. Spaghetti shoes. Grams of K, 39.09. Grams, that equals a mole. Chromium. Ooh, we haven't used chromium too many times. 51, let's just call that 52. And that equals a mole. And then oxygen we use quite a bit. That equals a mole. So first things first, convert each one of these to a mole. 26.6 divided by 39.09, that gives you 0.6805. Okay? And then the next one, 35.4 divided by 52, gives you 0.6807. Ooh, look at those two. Pretty close, but which one's the lower? This, but there's still going to be one. You can already see it kind of forming together. 38.1 divided by 16. Oh my Lanta, look at this one. 2.381. Okay, so these are all mole ratios. So once you have your mole ratio, remember you have 3 mole ratios here because you have 3 elements here. So we're going to divide each one of them by the smallest one. 0.605, 0.6805, woo, 5, 0.6805. Of course that's 1, of course that's 1. Let's see what this one equals. Uh-oh. 3.49. 3.49. Now, for us, we're going to call that 3.5. Now, if you guys think back to when we did the combustion reactions, what did we do with the halves? What did we do with the halves? We can't round it to 4, because what are you going to do with those? Again, it's like making cookies. Once you do one to one of the ingredients, you have to do them to all of them. So, best thing to do here is probably going to double it. So if you double that, that gives you 7. If you double this, that gives you 2 now. If you double that, that gives you 2. Okay? So when you get a half, you're going to just double it. All right? So our formula is now K2 Cr2 O7. K2 Cr2 O7. All right? Now, here at the bottom, we aren't going to do molecular formulas. We're going to save that till Monday. So let's do another set here for you guys. This little guy right here, it's kind of hard to see, is astatine. Astatine. AS. Okay? So, again, you have percentages. I know, I didn't give you that much room to work, but just write small. So instead of doing percentages, we know that it's going to be grams. So we're going to go 36 grams of, and then we're going to go 30.8 grams of oxygen. Now we know that our formula, I just like writing them in order. So it's going to be Na something, As something, O something. So convert them to moles, first things first. So that's 23 grams. Astatine, 75. 1 mole. And 16 grams. That's also a mole. All right. So let's see here. You guys see that? Maybe a little bit. 33.2 divided by 23. 1.443. 1.443 moles. 36 divided by 75. 0.48 moles. And then 30.8 divided by 16. 1.925 moles. Okay, so when you look at all this data here, once you get your molar-mole ratio, you're going to divide by the smallest one. So 0.48 is going to be our smallest one. So 0.48 divided by itself is that. 1.443 divided by 0.48 equals 3. And then 1.925 divided by 0.48 is 4. All right. So 3, 1. Did I do that? Yes, I did that right. 314. Don't write ones. So Na3ASO4. That will be your formula. Let's do another one. Uno más. One more. Let's do number 3. Let's do number 3. Okay? So this one is not in percentages. This one's in grams. So either way, just make it grams. 0.592 grams of nitrogen and 2.441 grams of fluorine. Fluorine. So you know, N and F, it's going to have N and F for its formula. Change it to moles. Guys, this is easy. 14, 1 mole. Fluorine is 19 grams is a mole. Divide them out. 0.592 divided by 14. Oh, 0.0423. 2.441 divided by 19. Getting a little scrunched here. Equals 0.1285. So, divide by the smallest. That equals 1.0423. You can look at this. Use your noggin here, folks. What is 12 divided by 4? Don't even use a calculator. Look at your numbers. Okay? So we have NF3. NF3. Okay? So, you guys should be able to go through and continue to work on this and get better at it. And then, let's see. Yes. So you should be able to finish out this sheet as well as look at the next sheet. Same thing. Empirical formula, empirical formula, empirical formula. Okay? Look at all this. Oh yeah, baby. So, you guys have some work to do. So, practice, practice, practice. But this should help you out a lot. Worst case scenario, if you have any questions, Miss Moore is across the hallway. Go ask her right quick. But I think you guys will be great. This is not very difficult. So, I hope all is well. Miss you guys. I will see you on Monday when we have another video. So, toodles!